So last topic remaining is the transformer. So what is transformer? Transformer is a device which is used to increase or decrease the AC voltage. So that device we call as a transformer, right? So it is a device used to increase or decrease the AC voltage. So while studying the advantages of AC over the DC, we discussed about the topic that is the transformer. So with the help of the transformer, we can increase or decrease the AC voltage, right? So it works from the principle that is mutual induction. So it works on the principle of mutual induction. So ಇದನ್ನು ನಾವು electromagnetic induction study ಮಾಡಬೇಕಾದ್ರೆ so here ನಾವು ಆ ಚಾಪ್ಟರ್ ಸ್ಕಿಪ್ ಮಾಡಿರೋದ್ರಿಂದ so mutual induction is a property. So ಈ ಪ್ರಾಪರ್ಟಿ ಮೇಲ್ಗಡೆ ನಮಗೆ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ ಏನಾಗುತ್ತೆ ವರ್ಕ್ ಆಗುತ್ತೆ, right? So on what principle the transformer works means the transformer works on the principle that is mutual induction, right? So next, the transformer consists of two coils or inductors, right? So it consists of the two coils or two inductors, right? So these are they are wound on the soft iron core, right? So iron core, if you consider this one as one iron core, right? So on to this iron core, this shaded part is here. So this we call as iron core, right? So transformer, it consists of two coils. So coil is nothing but the inductor. So we represent that one as like this. So this represents what? The symbol of the coil. So it consists of two coils, or we call that one as inductor. So these coils are wound onto the iron core in such a way that, so here we have two different types. We can wound the coil onto this iron core. So the first one is on one top of the other. So one coil ಮೇಲೆ ಇನ್ನೊಂದು coil ನ wound ಮಾಡ್ತಿದೀವಿ. So two coils na first, if we take this one, right? So this is one coil, right? So one coil which is wounding onto the core, right? So this we call as the iron core. So e iron core mele one coil na wound ಮಾಡಿದೀವಿ, right? So on the top of this coil we are wounding one more coil, right? So like that. So this is the another coil, right? So two ways in of coil na wound ಮಾಡಬಹುದು. One method is one coil which is wounded on the top of the other. So ಒಂದು ಮೇಲ್ಗಡೆ ಇನ್ನೊಂದು coil na wound ಮಾಡ್ತಾ ಇದೀವಿ. So that is one method. So on the another method is two coils wound on two different limbs of iron core. So ಇದನ್ನ single limb ಅಂತ ಕರೀತೀವಿ. So the another one is, so again this we taken as iron core. So ಈ iron core ನ ನಾವು laminate ಮಾಡಿರ್ತೀವಿ, that means insulating material ಇಂದ. So that's why we are shading those parts. So this is one coil. So on the another limb we are moving another coil. So these are the two coils which we can wound on the soft iron core. So this is also called as iron core, right? So ಎರಡು ಮೆಥಡ್ ಅಲ್ಲಿ ನಾವು wound ಮಾಡಬಹುದು. One is top of one over the another. First one coil na wound ಮಾಡ್ತೀವಿ on one limb of the iron core. So first one coil na wound ಮಾಡಿದ್ಮೇಲೆ ಆ coil ಮೇಲೆ ಇನ್ನೊಂದು coil na ನಾವು wound ಮಾಡ್ತಾ ಇದೀವಿ. So that is one top over the other. One top of the another, right? So in the second case, one coil is wounded to one limb of the iron core, that means one branch, right? So another coil is wounded on the another limb of the, right? So these are the two methods to wound the coil of the iron core, right? So here we have the two coils. So ಈ ಎರಡು coil ಅಲ್ಲಿ we can say one coil as primary coil of turns NP. So NP represents what? Number of turns. So ಇದು turns ಇದೆ ಅಲ್ಲ, so ಇದನ್ನ ಕೌಂಟ್ ಮಾಡೋದನ್ನ ಏನಂತ ಕರೀತೀವಿ ನಾವು? Number of turns. So ಅದು ಎಷ್ಟು ಕಾಯಿಲ್ ನ ಎಷ್ಟು ಟರ್ನ್ಸ್ ಅಲ್ಲಿ ನಾವು wound ಮಾಡಿರ್ತೀವೋ ಅದನ್ನ ನಾವೇನಂತ ಕರೀತೀವಿ? Number of turns. So ನಮಗೆ ಎರಡು ಕಾಯಿಲ್ ಇದೆ. So ಎರಡು ಕಾಯಿಲ್ ಅಲ್ಲಿ we can choose any one coil as a name. That one as primary coil. So ಒಂದನ್ನ ನಾವೇನಂತ ಕರೀತೀವಿ? Primary coil. So this coil having the number of turns. So difference irutte primary coil ge matte secondary coil ge, right? So that is the difference is in the number of turns. So ಒಂದರಲ್ಲಿ ಜಾಸ್ತಿ ಟರ್ನ್ಸ್ ಇರಬಹುದು ಅಥವಾ ಒಂದರಲ್ಲಿ ಕಮ್ಮಿ ಟರ್ನ್ಸ್ ಇರಬಹುದು. So ಅದನ್ನ ನಾವು ಏನಂತ ಡಿಫರೆನ್ಶಿಯೇಟ್ ಮಾಡ್ಕೊಂಡಿದೀವಿ by giving the names. So one is primary coil and that primary coil having the number of turns NP, right? So the another coil that we call as secondary coil having number of turns denoted by NS, where N is the number of turns. So suffix P represents what? Primary coil, and here S suffix S represents what? The secondary coil, right? So ಒಂದನ್ನ ನಾವು primary coil ಅಂತ ಕರೀತೀವಿ, ಇನ್ನೊಂದನ್ನ secondary coil ಅಂತ ಕರೀತೀವಿ, right? So next, so this is the basic construction of the transformer. So transformer ಅಲ್ಲಿ ನಮಗೆ ಏನಿರುತ್ತೆ? Two coils ಇರುತ್ತೆ. So two coils ನ wound ಮಾಡ್ತಾ ಇದೀವಿ. ಯಾವುದ್ರ ಮೇಲೆ ಅಂದ್ರೆ ಐರನ್ ಕೋರ್, ಸಾಫ್ಟ್ ಐರನ್ ಕೋರ್ ಮೇಲ್ಗಡೆ ಮೌಂಟ್ ಮಾಡ್ತಿದ್ವಿ ಅಥವಾ ವೈಂಡ್ ಮಾಡ್ತಾ ಇದೀವಿ, ರೈಟ್? ಸೊ ಎರಡು ಕೇಸಸ್ ಅಲ್ಲಿ ನಾವು ವೈಂಡ್ ಮಾಡಬಹುದು. ಒನ್ ಇಸ್ ಒನ್ ಟಾಪ್ ಆಫ್ ದ ಅದರ್. ಫಸ್ಟ್ ಒನ್ ಕಾಯಿಲ್ ನ ನಾವು ವೈಂಡ್ ಮಾಡಿ ಆ ಕಾಯಿಲ್ ಮೇಲೆ ಸೊ ಅನದರ್ ಕಾಯಿಲ್ ನ ವೈಂಡ್ ಮಾಡ್ಕೊಂತೀವಿ, ಅಥವಾ ಸೊ ಎರಡು ಸಪರೇಟ್ ಲಿಂಕ್ಸ್ ಮೇಲೆ ನಾವು ಒಂದನ್ನ ಪ್ರೈಮರಿ ಕಾಯಿಲ್ ನ wound ಮಾಡಿದ್ರೆ ಇನ್ನೊಂದನ್ನ secondary coil na wound ಮಾಡ್ತೀವಿ. So this is the basic construction of the transformer. So let's discuss how it will increase and decrease the AC voltage. So here by choosing this diagram, so iduna ನಾವು ಏನಂತ ಕರೀತೀವಿ primary coil of turns NP. So ಇದರಲ್ಲಿ ಎಷ್ಟು turns ಇರುತ್ತೆ, number of turns, we call that one as NP, and here we call this one as secondary coil. So in this coil it has the number of turns, that is NS. So NS is the number of turns in the secondary coil and NP is the number of turns in the primary coil. Now connect the primary coil to the AC source. So iduna ಏನು ಮಾಡ್ತೀವಿ ನಾವು, we are subjected this to the AC source of voltage V. So we are supplied or we connected the primary coil of the transformer. So these two combination na navenanta karitidೀವಿ transformer anta karitತೀವಿ. So primary coil of the transformer magnetic flux, because so ಯಾವುದಾದರೂ ಒಂದು ಕಂಡಕ್ಟರ್ ಅಲ್ಲಿ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗ್ತಿದೆ ಅಂದ್ರೆ so that conductor acts as magnet, right? So ಇದನ್ನ ನಾವು ನೆಕ್ಸ್ಟ್ ಚಾಪ್ಟರ್ಸ್ ಅಲ್ಲಿ ಸ್ಟಡಿ ಮಾಡ್ತೀವಿ, ಬಿಕಾಸ್ ಇದಿಷ್ಟು ಕವರ್ ಮಾಡಿ ಇಲ್ಲಿ ಬರಬೇಕಾಗಿತ್ತು. ಸೊ ಡೈರೆಕ್ಟ್ ಆಗಿ ಈ ಚಾಪ್ಟರ್ ಬಂದಿರೋದ್ರಿಂದ ಈ ಕಾನ್ಸೆಪ್ಟ್ ಅಲ್ಲಿ ಬೇಸಿಕ್ ಎಷ್ಟು ಬೇಕೋ ಅಷ್ಟು ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ತೀವಿ. ಸೊ ಯಾವ್ದಾದ್ರು ಒಂದು ಕಂಡಕ್ಟರ್ ಅಲ್ಲಿ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗ್ತಿದೆ ಅಂದ್ರೆ ಅಂತ ಕಂಡಕ್ಟರ್ ನ ನಾವು ಮ್ಯಾಗ್ನೆಟ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ದಟ್ ಮ್ಯಾಗ್ನೆಟ್ ಇಸ್ ವಾಟ್, ದ ಎಲೆಕ್ಟ್ರೋ magnet. So magnet which is produced by the flow of current in the conductor, so that type of magnet we call as electromagnet. So here also coil is nothing but conductor. So in conductor alli current flow ಆಗ್ತಿದೆ ಅಂದ್ರೆ it behaves as a electromagnet and it produces a magnetic flux, right? So similar to electric flux, ಇಲ್ಲಿ ಏನಾಗ್ತಿದೆ ನಮಗೆ magnetic flux produce ಆಗುತ್ತೆ. As these magnetic flux which are links with the inductor, that is the coil, secondary coil, right? So magnetic flux primary coil alli produce ಆಗಿರೋದು ಏನಾಗುತ್ತೆ, it links with the secondary coil. So secondary coil alli flux change ಆಗ್ತಿದೆ ಅಂದ್ರೆ that means because we are applying the alternating voltage means the current which is in the inductor is also the alternating current. That means its values varies from maximum to 0 and to the minimum, right? So ಈ ತರ ವೇರಿ ಆಗ್ತಾನೆ ಇರುತ್ತೆ ಕರೆಂಟ್ ಕೂಡ, right? So as ಒಂದ್ಸಲ ನಮಗೆ ಮ್ಯಾಕ್ಸಿಮಮ್ ಬರುತ್ತೆ, ಒಂದ್ಸಲ 0 ಬರುತ್ತೆ, ಒಂದ್ಸಲ ಮಿನಿಮಮ್ ಬರುತ್ತೆ. So similarly the current which produces the magnetic flux, so that flux also vary with respect to time, that is d pi by dt. So ಈ ಫ್ಲಕ್ಸ್ ಕೂಡ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ as time changes. So ನಮಗೆ ಮ್ಯಾಕ್ಸಿಮಮ್ ಬರ್ಬೋದು, ಕೆಲವು ಸಲ 0 ಬರ್ಬೋದು, ಕೆಲವು ಸಲ ಮಿನಿಮಮ್ ಬರ್ಬೋದು, right? So this is the flux changes with respect to time. So these fluxes are linked with the secondary coil. So this flux, rate of change of flux, it induces the EMF in the secondary coil, right? So that we call as ES, right? So change of flux when linked with the secondary coil, so this coil induces the EMF, so that EMF we call as ES, right? So EMF is induced in the secondary coil, right? So that we taken as ES, that is equals to, so ಇಲ್ಲಿ ನಮಗೆ EMF produce ಆಗ್ತಿದೆ ಅಂದ್ರೆ so that EMF is directly depend on the number of turns in the coil, right? So ನಮಗೆ ಎಷ್ಟು EMF produce ಆಗ್ತಿದೆ ಅನ್ನೋದನ್ನ ಹೇಳೋದು ಯಾವ್ದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ, number of turns in the coil, right? So from this we can write the relation ES is equals to minus NP d pi by dt, right? So this is the mathematical relation to get the EMF in an inductor, right? So here where NP is the number of turns in the secondary coil and d pi by dt is the rate of change of flux, because we are supplying the alternating voltage. So now direct current flow ಮಾಡಿದ್ರೆ ಇಲ್ಲಿ ಯಾವುದೇ ತರದ್ದು magnetic flux produce ಆಗೋದಿಲ್ಲ. Only the magnetic flux is produced when it is varying with respect to time. That means current change ಆಗ್ತಾ ಹೋದಂಗೆಲ್ಲ it produces the magnetic flux. So ಆ ಚಾಪ್ಟರ್ ಅಲ್ಲಿ ಬಂದಾಗ ನಾವು in detail ಆಗಿ ಸ್ಟಡಿ ಮಾಡೋಣ. Just we know this one. So alternating flux ಇದ್ದಾಗ ಮಾತ್ರ ನಮಗೆ ಏನು ಪ್ರೊಡ್ಯೂಸ್ ಆಗುತ್ತೆ, EMF. So that EMF is directly depends on the number of coil, that is number of turns which are present in the secondary coil, right? So that is denoted by ES is equals to minus Np d pi by dt, right? So this we taken as first equation, right? So here EMF is producing nothing but the current is producing in the secondary coil also. So ನಮಗೆ EMF produce ಆಗ್ತಿದೆ nothing but voltage generate ಆಗ್ತಿದೆ ಅಂದ್ರೆ ಅಲ್ಲಿ ಏನು flow ಆಗ್ತಿರುತ್ತೆ current flow ಆಗ್ತಿದೆ. As the current is flowing, so again this is also the alternating current. So as the current is flowing in the secondary coil, so here also it generates the flux, right? So that flux will links with the primary coil. So illi produce after flux, it links with the primary coil and the current is produced or EMF is produced in this coil also, right? So that we taken as EP. So EP is the EMF which is produced by the secondary coil. So that EMF we call as back EMF, right? Back EMF is induced in the primary coil, right? So that we taken as EP, right? So here also the induced EMF is depends on the number of turns in the primary coil, right? So EP is equals to minus NP. This is N as secondary coil, right? So NP d pi by dt. So this we taken as second one. So ಇಲ್ಲಿ ಪ್ರೊಡ್ಯೂಸ್ ಆಗಿರೋ EMF ಯಾವ್ದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ number of turns in the secondary coil. So here also the current is produced, current is flowing in the inductor, so that generates the electric magnetic flux. So due to that magnetic flux which links with the primary coil, so here also EMF is induced, so that EMF we call as back EMF. So idrinda illi EMF induce agide. Again due to this EMF is induced in the primary coil, so that EMF we call as back EMF, right? So ES and EP are the EMF which are produced in the secondary coil and primary coil, right? So here considering or imagine or considering coil has negligible resistance. So considering these two coils having the negligible resistance, that means there is no resistance in these two coils, right? So again we know the relation, that is V is equals to E minus I into R. So this is from the current electricity, that is EMF of a cell, that is EMF which is produced in a cell. So here also we are getting the same relation, right? So we consider such a case that there is no resistance in these two coils, right? So that means the resistance is 0, that means I into R is 0, so this volt turns becomes 0, right? So EMF produced across the secondary coil, that is equals to the voltage across the secondary coil. EMF produced across the primary coil, that is the voltage across the primary coil. So from this we can write Vs, that is equals to Es, right? And also Vp is equals to Ep. So now we can write these two equations as Vs, that is equals to minus Ns d pi by dt, calling this one as third equation. That is from this relation. So this statement is very important. So considering the negligible resistance, then only we get voltage is equals to the induced EMF, right? So similarly Vp is equals to minus Np dp by, that is d pi by dt. So that becomes equation 4. Now divide equation 3 by equation 4, right? So Vs divided by Vp, that is equals to minus Ns d pi by dt, 4 divided by minus Np d pi by dt, right? So d pi by dt get cancels, minus minus get cancels, so remaining we get it Vs by Vp, that is equals to Ns by N, right? So Vp is the input voltage and Vs is the output voltage, right? So we need to find the output voltage Vs, that is V Ns by Np into Vp. So this is the final expression in transformer, right? So this is the relation to get the output voltage. So the main purpose of the transformer is to vary, increase or decrease the AC voltage. So now AC voltage ಕಡಿಮೆ ಕೊಟ್ಬಿಟ್ಟು ಔಟ್ಪುಟ್ ಅಲ್ಲಿ ಜಾಸ್ತಿ ತಗೋಬಹುದು ಅಥವಾ ಇನ್ಪುಟ್ ಅಲ್ಲಿ ಜಾಸ್ತಿ ಕೊಟ್ಬಿಟ್ಟು ಔಟ್ಪುಟ್ ಅಲ್ಲಿ ಕಡಿಮೆ ತಗೋಬಹುದು. So that is depends on Vs, this relation Vs by Vp is equals to Ns by Np, where Vs is the voltage across the secondary coil, Vp is the voltage across the primary coil, right? Here we represent this one as Vs and here this is Vp. So initially we applied voltage is V or Vp, right? And now this Ns by Np, we call this one as turn ratio and it is denoted by capital T. So ಈ ratio ನಾವು ಏನಂತ ಕರಿತೀವಿ turn ratio, because number of turns in the secondary coil to the number of turns in the primary coil, we taken that one as one ratio. So it has no unit, so hence we call that one as turn ratio T, right? So if T is greater than 1, so turn ratio value is greater than 1, that means Ns value, number of turns in the secondary coil, is greater than number of turns in the primary coil, then that transformer we call as step up transformer. So number of turns in the secondary coil ಜಾಸ್ತಿ ಇದ್ದು number of turns in the first coil, primary coil ಅಲ್ಲಿ ಕಡಿಮೆ ಇತ್ತು ಅಂದ್ರೆ ಅಂತ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ ನಾವು ಏನಂತ ಕರಿತೀವಿ, step up transformer, right? So second case, if T is less than 1, Ns is less than Np, that means secondary coil ಅಲ್ಲಿ turns ಕಡಿಮೆ ಇದ್ದು first coil ಅಲ್ಲಿ turns ಜಾಸ್ತಿ ಇತ್ತು. So in this diagram primary has less turns, that means 1 2 3 4. So primary ಅಲ್ಲಿ only 4 turns ಇದೆ, so secondary ಅಲ್ಲಿ 1 2 3 4 5 6 turns ಇದೆ, that means the secondary coil has more turns than primary coil. So here the turn ratio is greater than 1, so this transformer we call as step up transformer, right? So same, if we consider this as the primary coil and this one as the secondary coil, so AC source is applied across the primary coil, right? So iduna primary coil anta consider madidre number of turns in the primary coil is more than the number of turns in the secondary coil, so that we call as step down transformer, right? So these are the two types of transformer we naming. So based on the turn ratio, so number of turns secondary coil ಅಲ್ಲಿ ಜಾಸ್ತಿ ಇದ್ರೆ ಅದನ್ನ step up transformer ಅಂತ ಕರಿತೀವಿ, number of turns in the primary coil ಅಲ್ಲಿ ಜಾಸ್ತಿ ಇತ್ತು ಅಂದ್ರೆ ಅದನ್ನ step down transformer ಅಂತಾನು ಕರಿತೀವಿ, right? So as we are getting the voltage, so there should be a power loss because we are applying the AC source to the coil, right? So power loss or critical power loss across secondary coil. So power loss across the secondary coil, we know that the relation P is equals to I into V, right? So where V is the voltage across the secondary coil and P is the power loss across the secondary coil, right? So where I is the current which is flowing in the secondary coil, right? So Is Vs, right? So similarly power loss across primary coil, right? So that is P is equals to Ip Vp, right? So efficiency of a transformer. So efficiency of a transformer, that is eta, that is equals to output power to the input power. So now primary coil ಗೆ ಯಾವಾಗಲೂ AC source connect ಮಾಡೋದ್ರಿಂದ, so we call this one as the input power. So secondary coil ಅಲ್ಲಿ ಯಾವಾಗಲೂ ನಮಗೆ output ತಗೊಳ್ಳೋದ್ರಿಂದ we call this one as output power. So primary coil ಹತ್ರ ಇರೋದನ್ನ input power ಅಂತ ಕರೀತೀವಿ, right? So now substituting these two values, so N is equals to, so output power is IS Vs divided by IP. So this is the efficiency of a transformer, right? So in ideal case, the efficiency of a transformer is 100%. So when there is no losses in the transformer, so there is some losses, that is here we taken power losses, right? So power dissipated or power. So here we take directly power across secondary coil and power across the primary coil, right? So here some losses are there, so hence we are not getting the 100% efficiency of the transformer. So now ಎಷ್ಟು input ಕೊಡ್ತೀವೋ ಅಷ್ಟು output ನಮಗೆ ಯಾವಾಗಲೂ ಸಿಗೋದಿಲ್ಲ. So ideal cases ಅಲ್ಲಿ ಮಾತ್ರ ನಮಗೆ ಎಷ್ಟು input supply ಮಾಡ್ತೀವೋ ಅಷ್ಟು output ಬರುತ್ತೆ. So in regular cases ಅಲ್ಲಿ there are some losses in the transformer. So due to those losses we are not getting the 100% efficiency. That is, as we applied the input voltage, for example, if we applied the input voltage 100 volt, so exactly we won't get the output voltage as 100 volt. Either it might be some 90 volts or some 80 volts. So there is a 20% loss in the output, right? So now 100 voltage input voltage ಅಂತ ಸೆಟ್ ಮಾಡಿದ್ರೆ ನಮಗೆ output ಅಲ್ಲಿ we get lesser than the 100 voltage. That is due to some losses in the transformer, right? So now assuming the efficiency of a transformer is 100%, right? So this efficiency is 100%. So idu namge 100% ಯಾವಾಗ ಬರುತ್ತೆ when the output power is equals to the input power, right? So output power is equals to input power. So this is when assuming efficiency is 100%. So now input ಎಷ್ಟು ಕೊಡ್ತಿದೀವೋ ಅಷ್ಟು ಯಾವಾಗ ಬರುತ್ತೆ ಅಂದ್ರೆ when the efficiency of a transformer is 100%, right? So output power is equals to input power. So output power we take that one as IS Vs, that is equals to IP Vp, right? So from this we can write Vs by Vp, that is equals to IP by Is. So this we taken as first relation. This we can take second relation, right? So comparing the first relation and the second relation, in the LHS we having the same common terms, that is the ratio Vs by Vp, and here also Vs by Vp. So from this we can write Vs by Vp, that is equals to Ns by Np, that is equals to Ip by Is. So this is the overall relation in the transformer. So transformer ಅಲ್ಲಿ ನಮಗೆ current ಇದೆ, ಜೊತೆಗೆ voltage ಇದೆ, and the number of turns. So only the three factors we are discussing in the transformer, right? So one is voltage, and again the number of turns and the current in the coil, right? So from this we can generally write V is equals to N, and that is equals to 1 divided by I. Or we can write this one as V is proportional to N, N is proportional to 1 by I, right? So if we consider Vs, so Vs is directly proportional to Ns and it is inversely proportional to Is. So that's written here, Vs is equals to Ns and divided by Is. So if we take on Vp, so Vp is equals to Np and it is inversely proportional to Ip. So this gives to the numerator, so here we getting Ip. So this is the relation between the voltage and to the number of turns in the transformer, and this is the relation for voltage and to the current in the transformer, right? So this is all about the transformer. So ನಿಮಗೆ maximum 3 marks ಗೆ ಕೇಳಬಹುದು. So main important is this one: step up transformer, step down transformer, and the voltage and current relation in the transformer. So 1 marks ಗೆ ಕೇಳ್ತಿರ್ತಾರೆ. So ಅದು ಬಿಟ್ರೆ ನಿಮಗೆ explanation rare cases ಅಲ್ಲಿ ಕೇಳಿರೋದು, right? So efficiency of the transformer, output power by input power. When the efficiency is 100%, we get the relation Vs by Vp is equals to Ip by Is. So in the real cases, we won't get the 100% efficiency in the transformer. So there is some losses. So we will discuss energy losses in transformer. So it is important. 2 marks ಗೆ ಕೇಳ್ತಾ ಇರ್ತಾರೆ. So mention the energy losses in transformer ಅಂದ್ರೆ only mention ಮಾಡಬೇಕು. So explanation is necessary ಇರೋದಿಲ್ಲ. Energy losses transformer. So important for 2 marks. So in that first one is copper loss, right? So what is copper loss means? Now ಇಲ್ಲಿ coils na use ಮಾಡ್ತಾ ಇದೀವಿ. So these coils are made up of the copper. So these are wounded on the iron core which is made up of the copper, right? So as the current which is flowing across the coil, so right, so if we consider generally here, so this is the copper coil which is wound on this iron core, right? So as the current which is flowing in this coil, so ಇದರಲ್ಲಿ ಸ್ವಲ್ಪ resistance ಇರುತ್ತೆ, because ideal cases ಅಲ್ಲಿ ಮಾತ್ರ ಇಂಡಕ್ಟರ್ ಅಲ್ಲಿ ಏನಿರಲ್ಲ resistance ಇರೋದಿಲ್ಲ, right? So in normal cases ಅಲ್ಲಿ it has some resistance, right? So as the AC current which is flowing through the coil, so here due to the Joule's law of heating, so illenagutte heat produce agtide, right? So heat produce nothing but there is a loss of energy. So heat is a form of energy, right? So as the current is flowing in the coil, so coil gets heated due to the resistance of the coil, right? So hence by the Joule's law of heating, the coils gets heated, and that loss we call as copper loss, right? So copper loss is nothing but when the current is flowing in the coil gets heated, that is due to the Joule's law of heating, right? So heat is also a form of energy, so hence the energy is lost when current is flowing in the coil, right? So that we call as the copper loss. So how to minimize this copper loss? By using thick copper coil. So by using thick copper coil. So coil ದಪ್ಪ ಆದಂಗೆಲ್ಲ heating, that means heat energy loss ಆಗೋದೇನಾಗುತ್ತೆ, ಕಮ್ಮಿ ಆಗುತ್ತೆ. So that we call as the copper loss. So minimization is by using the thick copper coil, right? So this is the first, that one is the copper loss. So and the second one is flux leakage loss. So ನಿಮಗೆ 2 marks ಅಲ್ಲಿ ಮೆನ್ಷನ್ ಮಾಡಿದ್ರೆ only just you need to write the copper loss. So if they mention how to minimize, then only you need to write the minimize, right? So ಇದಕ್ಕೆ explanations ಕೂಡ necessary ಇಲ್ಲ. In case of they ask for 2 marks, just write the points. So energy losses in transformer means first one is copper loss, so second one is flux leakage loss, right? So here in the name itself saying the flux leakage, right? So flux leakage means the leakage of the flux in the air. So primary coil in the secondary coil ಹೋಗಬೇಕಂದ್ರೆ, so there is a air gap between the coils, 2 coils, or these flux will move in any direction, right? So as these fluxes are moving in any direction, so the number of flux which are generated in the primary coil will not link with the secondary coil. So ಇಲ್ಲಿ ನಮಗೆ d pi by dt, so some value 10 generate ಆಗ್ತಿದೆ ಅಂದ್ರೆ, so same 10 will not reach us the secondary coil, so it is less than some we getting 8, right? So ಎಷ್ಟು generate ಆಗುತ್ತಾ ಅಷ್ಟು ಇಲ್ಲಿ ನಮಗೆ reach ಆಗ್ತಿಲ್ಲ, so that is flux leakage in air, right? So hence that we call as flux leakage loss, right? So how to minimize? So how to minimize means we need to choose one coil which is wound on the another coil. So two methods of coil wounding ittala. So one coil mele innond coil wound madidre illi ಎಷ್ಟು flux generate ಆಗ್ತಿದೆ, so same flux will reach us the secondary coil. So there is no intermediate air space between the two coils. So hence the leakage will be reduced, right? So wound one coil on another coil. So ಈ ತರ wound ಮಾಡಿದಾಗ ನಮಗೆ ಏನಾಗುತ್ತೆ, flux leakage loss ಏನಾಗುತ್ತೆ, ಕಡಿಮೆ ಆಗುತ್ತೆ, right? So next third one, eddy current loss, right? So as we kept this transformer in a non-magnetic field, right? So non-linear magnetic field. So ಯಾವುದಾದ್ರೂ ಒಂದು magnetic field ಅಲ್ಲಿ ನಾವು ಈ transformer ನ place ಮಾಡಿದ್ರೆ, so due to the non-magnetic field, so magnetic fields vary ಆಗ್ತಾ ಇದ್ರೂ ಕೂಡ ಏನಾಗುತ್ತೆ, current is produced in the coils. So that current we call as the eddy current. So as the eddy current is flowing in the coil, again by the Joule's law of heating, so there is a power loss, right? So energy ಏನಾಗುತ್ತೆ ನಮಗೆ radiate ಆಗುತ್ತೆ from the coil, right? So that loss we call as the eddy current loss. So this is arised when we place the transformer in a non-magnetic field, right? So that means varying magnetic field ಅಲ್ಲಿ ಇದನ್ನ place ಮಾಡಿದ್ರೆ, so eddy current produce ಆಗುತ್ತೆ. So those eddy currents again will flow through the conductor, right? So heat is produced in the coil, right? So coil ಅಲ್ಲಿ heat produce ಆಗುತ್ತೆ, so that loss we call as eddy current loss, right? So how to minimize? So how to minimize this one is, so core is laminated or by laminating the core. So transformer core na ನಾವೇನ್ ಮಾಡ್ತೀವಿ, insulating. So insulating material ಇಂದ ಅದನ್ನ coat ಮಾಡ್ತೀವಿ. So ಅದರಿಂದ ಏನಾಗುತ್ತೆ ನಮಗೆ, it will not interact with the magnetic field. So hence there will be no flow of current in the core, and so we will minimize the eddy current loss. So minimize is by laminating the core, right? So on the last one is hysteresis loss, right? So this is caused by again magnetizing and demagnetizing. So ಇದರಲ್ಲಿ conductor varying current flow ಆಗ್ತಿರೋದ್ರಿಂದ, once as the maximum current is flowing, so positive value ಅಲ್ಲಿ current ಹೋಗ್ತಾ ಇದ್ರೆ coil ಏನಾಗುತ್ತೆ, magnetic field, that means magnetic fields na produce ಮಾಡುತ್ತೆ. So it becomes as magnet. When it reaches the negative value, again it becomes demagnetized. So current ಯಾವಾಗ flow ಆಗುತ್ತೋ ಅವಾಗ magnet ಆಗುತ್ತೆ, so ಯಾವಾಗ current flow ಆಗೋದಿಲ್ಲ ಅವಾಗ demagnetize ಆಗುತ್ತೆ. So that is the magnetizing and demagnetizing of the coils, right? So magnetize ಆಗುತ್ತೆ ಮತ್ತೆ demagnetize ಆಗುತ್ತೆ. So due to this, so there is a heating produce. So ಇದರಿಂದನೂ ಕೂಡ ಏನಾಗುತ್ತೆ ನಮಗೆ heat produce ಆಗುತ್ತೆ, right? So due to this heating, so again there is a loss. So that loss we call as the hysteresis loss. So how to reduce the hysteresis loss means, so less demagnetizing or less heat producing. So less heat producing materials na use ಮಾಡೋದ್ರಿಂದ ಕೂಡ ನಾವು hysteresis loss na ಕಡಿಮೆ ಮಾಡಬಹುದು, right? So that is about the energy losses in the transformer. So here heat is produced due to magnetizing and demagnetizing by the coils. ಸೊ ಈ ಕಾಯಿಲ್ ಅಲ್ಲಿ ಮ್ಯಾಗ್ನೆಟೈಸ್ ಆಗುತ್ತೆ ಮತ್ತೆ ಡಿಮ್ಯಾಗ್ನೆಟೈಸ್ ಆಗುತ್ತೆ, ಸೊ ಅದರಿಂದ ಹೀಟ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಗುತ್ತೆ. ಸೊ ಅದಕ್ಕೋಸ್ಕರ we getting the hysteresis loss. So these are the important energy losses in transformer. So ಇದನ್ನ ಇಂಡಿವಿಜುವಲಿ ನಾವು ಮ್ಯೂಚುವಲ್ ಇಂಡಕ್ಷನ್ ಅಥವಾ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಪ್ರಾಪರ್ಟೀಸ್ ನ ಸ್ಟಡಿ ಮಾಡಬೇಕಾದ್ರೆ ಇದನ್ನ ಇಂಡಿವಿಜುವಲ್ ಆಗಿ ಸ್ಟಡಿ ಮಾಡ್ತೀವಿ. ಜಸ್ಟ್ ಹಿಯರ್ these are the key points in the energy losses in transformer, right? So in the next class we will solve problems. So ಈ ಚಾಪ್ಟರ್ ಅಲ್ಲಿ ನಮಗೆ ಮ್ಯಾಕ್ಸಿಮಮ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಬರೋದ್ರಿಂದ, so we will discuss problems on this chapter in our next class. Thank you.